In this section we're going to be talking about rational numbers, and we're going to add and multiply rational numbers. But first off, let's talk about the previous sections of how rational numbers are related to natural numbers and integers. So we normally label the set of rational numbers with the letter Q. And a rational number is nothing more than just a fraction. So that's a rational number. Negative 5 over 7 is a rational number, so we have negative numbers are rational. And 6 over 3, which is a rational number, but we can reduce this down to the number 2. So in a sense we could say 2 is a rational number. Actually, we can say 2 is a rational number. Now, how these guys are all related, first off, we started with the set of natural numbers. So I'm just going to kind of make a little box here. This is the set of natural numbers. So 2 is in this set, for example. And then we added 0 to the set, and we ended up with the set of whole numbers, and that's just a 0 added to it. And then we added the negatives. Okay, so this is the set of integers here. Okay, so for example, negative 2 is in this set. Now let me do this. What about if I had a negative 6 over 3? Well, I shouldn't have put a comma there. So this actually equals to a negative 2. So as you can see, for example, negative 6 over 3, which is a rational number, reduces down to negative 2, and negative 2 is an integer. So it turns out that all the integers can be expressed as a rational number. So the rational numbers, or I should say that the integers, are contained in the set of rational numbers. So this is the set here of rational numbers. Now what's out here is things like, for example, 2/7. Okay, we can't reduce 2/7 down any, so it can't be an integer or a natural number or any of those. Alright, so as you can see here, the natural numbers are a subset of the whole numbers are a subset of the integers, and this set here is labeled with the letter Z, kind of small to see, and then Z is a subset of Q. And I'm going to go ahead and write out how you'd actually say that. So mathematically, so Q is a subset of Z. I'm sorry, Q's not. Okay, hold on. I need to scratch that out. That's terrible. Sometimes we don't pay attention, we make mistakes. Okay, so N is a subset of the whole numbers, which I just labeled as W, and that's a subset of Z, and Z is a subset of Q. So mathematically, that's how you would write this out. Alright, we're going to work on now the operations, how to add two rational numbers together and how to multiply, sometimes I indicate with a dot, multiply two rational numbers together, and then we'll do both the combination of adding and multiplying. I think also, I believe this is the last video of this section here. I did leave out subtraction, but hopefully you can apply the addition. You can apply what you've learned to subtraction there. Okay. We're going to do a little review here on fractions, so this is just going to be a review. And so we're going to label this as fractions. And like I said, this is just a refresher to kind of refresh your memory. Okay, so let's do something simple here, like for example if I had 2/6 and we wanted to reduce that down. Well, 2 goes into 2 one time, and 2 goes into 6 3 times. So this is reduced down to 1/3. Let's look at another one over here. What about 4/8? Well, what's the largest number that goes into both 8 and into 4? Well, 4 goes into 4 one time, and 4 goes into 8 2 times. So this is just some couple examples here of simplifying a fraction. Now these are known as proper fractions because this up here, which remember is the numerator, and the number down here in the bottom is known as the denominator. And when the numerator is larger than the denominator, we say that this is a proper fraction. However, if we were to flip this around and we put a 6 up here and a 2 down here, okay, this is a improper fraction. And of course this reduces down to 2 goes into 6 3 times. So by taking this and flipping it, putting the 1 down below, if you flip this fraction and you put the 1 down below and put the 3 up top, that's the reciprocal. So these two are reciprocals of each other. Alright, so just some more terms that you need to keep up with. So quickly, this is a proper fraction and an improper fraction. Proper fraction, the numerator is larger than the denominator. Now these numbers are known as rational numbers. Rational numbers. Okay, let's work some more examples here. If I had 4/1, this reduces to 4. Okay, because 1 goes into 4 4 times. Now that that's said, what if I were to have 4 1/2? This is a mixed number. And to get this into a single fraction, which could either be a proper fraction or an improper fraction, you would simply say 4 plus a half, and then we can get this into, in this particular case, of course, this would end up becoming an improper fraction because the numerator would be greater than the denominator. But before we do that, let's talk about adding fractions. If I have a half and I were to add another half to it, as you can see here, the denominators are both the same, and if the denominators are both the same, then you would just rewrite the denominator and you would add the numerators. So I'm going to do this a step at a time here, and this becomes 2/2, which is equal to 1. And of course, intuitively, if you have a half of something plus a half of the other part of the whole, you would just get 1, right? So half and a half is 1. Okay, let's look at something different here. Like what happens if the numerators are different? Like for example, if I had a half and I were to add a third to this, well, as you can see, the denominators are not equal. So we need to get these denominators equal, and we're going to simply do that by doing something real simple. Okay, I'm going to multiply 3, or I'm going to put 3/3, which is just equal to 1, and then I'm going to write that part of the fraction, the half, and then I'm going to write 1/3, and then over here I'm going to end up putting 2/2. Simple enough. We have, actually let me change colors here. Let's go back to black. Okay, so what I've done is I put a 3/3 next to the half and a 2/2. And once we now multiply these two denominators here, which is going to give us a 6, and then 3 times 1 is 3 plus, and then of course 3 times 2 is 6. So as you can see now we have a common denominator, and of course 1 times 2 is 2. And since we have a common denominator, now what we can do is you rewrite the denominator and you add the numerators. So 3 plus 2 is 5. And as you can see here, we cannot reduce this down anymore. So 5, 6 has been totally reduced down, and now this is a what? It's a proper fraction. And also reminding you that this is known as a rational number. Let's look at some more examples. Okay, so let's say that we had 1/4 plus, we'll say 1/2. Now you notice our denominators are not equal, so we can't just add the denominators or multiply them. Some students get denominators, they add them, they multiply them, and do all kinds of crazy stuff. But what we want to do here is we want to get both these denominators to be the same. And the way we're going to do that, it's real simple. I am going to multiply this part of the fraction by 2 over 2. Now 2 over 2 is 1, and 1 times 1/2 is just 1/2. So we're not really doing anything here other than putting a 2 in the numerator and a 2 in the denominator. Now I'm going to go ahead and now rewrite this fraction. So rewriting the 1/4. So 2 times 2 is 4. And 1 times 2 is 2. So now as you can see, we have a common denominator. And so I rewrite the denominator and I add the numerators, which will be a 3. And as you can see, this will not reduce down any. And we have now our proper fraction. Alright, let's come up with another one here. What if we started out with 2/8 plus 1/4? Well, the first thing I would say is let's simplify this guy down first. Okay, let's simplify this down first before we actually start adding these together, because in the end we'll just end up having to simplify again. But it'll be much more difficult. So let's simplify this first. So the largest number that goes into both 2 and into 8 is going to be 2, and 2 goes into 2 one time, and 2 goes into 8 4 times. We have a common denominator, so we just rewrite the 4 and we add the numerators. Now of course we're going to end up simplifying this down, but it's not going to be as bad. So 2 goes into 2 one time, and 2 goes into 4 2 times. So our answer, so this is equal to 1/2. Well, this is adding two fractions together when their denominators are not equal. And remember, I'm just going through and just refreshing your memory on how to add fractions together. You're more than likely going to be working with much larger numbers here when you work some of the problems on this website. But this is just supposed to be a refresher. But what we need to look at next is multiplying fractions together. So we're going to do that next. Wait a minute. I need to go back and work a couple of those mixed fractions that I mentioned earlier. So let's just do that. Alright, so let's review. Remember that 4 can be rewritten as 4 over 1. Okay, so let's say that we had 4 plus 1/2. and we wanted to get this into one fraction here, an a over b. Well, what I would do is I would go ahead and write a 1 right down here. We have a 1 and we have a 2 now in the denominator. Let me rewrite this. 4 over 1 plus 1 over 2. We want to get a common denominator. Well, the best thing for me to do here is just to simply write 2 over 2. And now I'm going to rewrite this. So we now have 2 times 4, which is 8, over, and 2 times 1, which is 2, plus a half. Okay, we have common denominator, and the common denominator is 2, and then we can rewrite add the numerators, 8 plus 1, which becomes 9. So this is an improper fraction, but that's okay. That's okay. So what I need to say now is, if we were to have 4 halves, okay, so this is like something in the construction you might see, right? If you're in the working in construction, it says 4 halves, right, on the blueprint. Well, we want to convert that into one single fraction, right? In this case, a proper or improper fraction. You would just simply do it just like this. We would write 4 plus a half, and then of course get a common denominator like we did here, and then go through these following steps. So if I were to write 7 and 3/4, right, you would say 7 plus 3/4, and you would just go through these exact same steps, writing a 1 under the 7 here, and then multiplying 4 over 4. Okay, well, let's move on now in multiplying rational numbers. Alright, multiplication. Let's say, for example, we had a half, and we were going to multiply that by 5. Well, this can also be rewritten as 1 over 2 times 5 over 1, and remember 5 over 1 is just 5. Well, this is a lot easier. Multiplication of rational numbers is a whole lot easier than adding them. You just simply multiply the numerators together, and you multiply the denominators together. And of course I'm writing all these steps out step by step here. So 1 times 5 is 5, and 2 times 1 is 2. So that's simple enough. What if we had 3/4 times 1/2? You would multiply 3 times 1, which is 3, and 4 times 2, which is 8. So remember, this is a improper fraction because the numerator is greater than the denominator, and here we have a proper fraction. Alright, let me do another one here. 2/7 times 3/2. Now, as you can see here, we have a 2 in the numerator, a 2 in the denominator. You can actually cancel these guys out and then do the multiplication, which is going to end up becoming just 3/7. We'll work some more examples of those. Alright, let's look at another example. Alright, I'm going to construct, what I'm going to do here. Let me just go ahead and just write one out here. So 4 times 7, and sometimes you'll see parentheses around. It could be both of them or maybe either one. We'll say 7 over 8. Now before we multiply these two together, we need to try to simplify this down as much as we can. And as we can see here, there's a 7 in the numerator here, and then a 7 in the denominator here. So we can cancel these 7's out and just rewrite this as 4 over 8. And then of course now we would just simply simplify this down. 4 goes into 4 one time, and 4 goes into 8 two times. So we really don't want to multiply this stuff together. For example, 4 times 7 is 28, and then 7 times 8 is 56. And now what we've got to do is simplify this down. Right? So we don't want to do that. We want to simplify this down first as much as we can, and then we can reduce and so forth. What if I were to have a negative half? And I'm going to put a parentheses around this negative here. And we're going to multiply this by 10 over 17. Now we have a negative number times a positive number. And in the previous section on natural numbers and integers, we should know what a negative times a positive is. But this is a negative rational number. Okay, these are both rational numbers or fractions, but you can have negatives. Alright, let's do it. Let's simplify this first. We know that 2 goes into 10, and it goes into 10 5 times. And 2 goes into itself 1 time. So now I'm going to rewrite this. This becomes negative 1 over 1. And this becomes 5 over 17. Now, a 1 over 1 is just 1. So this is just a negative 1 times 5 over 17. And a negative 1 times 5 over 17, let me put a parentheses around this. So 1 times 5 over 17 is just 5 over 17, but you have a negative, so this just becomes a negative 5 over 17. Right, easy enough dealing with negatives. Alright, let's work another one out here. Let's say we had a half times 3/7 plus, let's say we've got 2/3 times 4. Alright, so we've now combined both addition and multiplication of fractions here together. So let's try to work this out. So there's no simplifying going on here, so this just becomes 1 times 3 is 3, and 2 times 7 is 14, plus, now what about this over here? Can we simplify this down? And no. So 2 times 4 is 8, and then we have a 3 in the numerator there. So we need to get a common denominator, and 3 doesn't go into 14 at all. So this doesn't look good, but we'll go ahead and we can work through this. So what I'm going to do here is I'm going to multiply this guy over here by 3 over 3, and this one 14 over 14. Okay, so 3 times 3 is 9. Now, 3 times 14, what in the world is that going to be? Well, we should come up with 42 on that. Plus, and 8 times 14 is a nice big number. Well, it's big compared to the numbers we've been working with. And of course, I'm going to rewrite this 42 here. So now we have a common denominator. So we're going to rewrite our denominator, which is 42, and now we're going to add the numerators. So that would be 112 plus 9, which is 121. Now the question is, will this reduce down any? And the answer is no. So this is not going to reduce down any at all, right? There's not a number that goes into both 121 and goes into 42 for this to reduce down at all. Well, that concludes the review over adding fractions and multiplying fractions together. So I sure hope that this helps you out.